For question number 10, we want to find the angle CAT. This is the angle. Now first, because this TA is the tangent, so you know that this is 90 degrees. So part A, first we have the angle TAB is equal to 90 degrees. And the reason is tangent perpendicular to radius. This question is not approved. It is finding the angle. This one, the reason you may skip it, but if you write the reason incorrectly, then mark will be deducted. And then next we consider in the triangle TAB. Then by the angle sum of triangle, 48 degrees plus 90 degrees plus the angle TBA, it is 180 degrees. This is angles sum of triangle. So you can get the angle TBA equal to 42 degrees. Now after you know this angle, we know that they are the same. So therefore angle CAT equal to angle TBA equal to 40 degrees. The reason is angle in alternate segments. And for part B, we want to show CO whether it is parallel to TA. Now according to the theorem, if you want to show two lines are parallel or not, either you prove the angle corresponding angles equal, or alternate angles equal, or interior angles supplementary. Okay, now so we need to find out, for example, if you want to use the alternate angle equal or not, then you can try to look at this angle. Okay, because these are the radii, so once we know this is 42, you can get this is 42, and then this is the diameter, so you know this is 90 degrees, so you can get this angle. So first, in triangle OCB, angle BCO equal to angle CBO equal to 42 degrees. This is the base angles, isosceles triangle. And the angle BCA is 90 degrees because angle in semicircle. Okay. So therefore angle OCA, it is 90 degrees minus 42 degrees, that is 48 degrees, which is not equal to CAT. So therefore CO is not parallel to TA. Now for question number 11, part C is quite difficult, but part A and B are not difficult. Now so for part A first, because f(x) is divisible by h plus 1, so by the remainder theorem, f of minus 1 should be 0. Okay? And then by the division algorithm, we know that f(x) when it is divided by h plus 2, so it is divisor multiply the quotient plus the remainder. Okay? So therefore f of minus 1 is, you put the minus 1 to the h, so minus 1 square minus 1 times minus 1 plus h plus 4 times minus 1 plus k, it is 0. But this one is 0, so you get k equal to 4. This is part A. Now part B, we have f(x) equal to h plus 1 times gx. So if you want to find the gx in terms of h, so first, by A, f(x) is x squared minus 1 times x plus h plus 4x plus 4, because the k you know it already. So you factorize this one is x plus 1, x minus 1, x plus h plus 4, x plus 1. And then you take out the common factor. So we have fx is x plus 1 times x minus 1 times x plus h plus 4. So if you're comparing these two forms, so you see that therefore gh is x minus 1, x plus h plus 4. Expand it, you have x squared plus hx minus x minus h plus 4. So we write into the standard form, it is something like this. Now for part C, we say that fx equal to 0 has two distinct real roots. But we already know that fx can be written as x plus 1 times the gh, that is x squared plus h minus 1, h plus 4 minus h equals 0. Okay? Now, so there are two cases. Now, case 1. This part, the gh has a repeated root. Therefore, together with minus 1, there are two distinct real roots. So, in order the gh has repeated roots, but the repeated roots cannot be minus 1, cannot be the same as this one. Okay, so we set the discriminant equals 0. So h minus 1 all squared minus 4 times 4 minus h equals 0. So we solve this one, expand it. So we have h squared plus 2h minus 15 equals 0. So h is equal to 3 or minus 5. So when h equal to 3, so gh actually is h squared plus 3 minus 3 is 2h plus 4 minus 3 is 1. That is h plus 1 all squared. So the root again is minus 1, so we have to reject it. Okay? Now, when h equal to minus 5, the gh actually is h squared minus 6h plus 9. So the repeated root is 3. So this is accepted. So h can be equal to 5. Now for case 2. Now the fx equal to h plus 1 times gh. So one of the roots is already equal 0. One of the roots is minus 1. And then for gh, we want to find the gh. It can only have two roots, because we have already considered gh as repeated root. Now if gh has two distinct roots, one of them must be minus 1. So therefore, g minus 1 must be 0. Now put the minus 1 into the expression. You have minus 1 squared minus h minus 1 plus 4 minus h equals 0. So simplify is 1 minus h plus 1 plus 4 minus h equals 0. So move these two to the other side is 2h. It is 6, so you get h is 3. But as we have proved here, when h is 3, gh has repeated roots. So it is contradicted. They are distinct roots, so this is also rejected. So finally, we have only one possible value for h. H can be 5 only. Question number 12. Now, originally, the 7200 is the total price, divided by y, then this is the price each student need to pay. But when we increase 12 students, then the amount they need to pay will be less. So the difference is already given to be 20. So you set up this equation and then just try to solve for it. So the first step is you combine the denominator. So it is 7200 times y plus 12 minus 7200y equal to 20. And then move this to the other side. So you have 7200y plus 7200 times 12 minus 7200y equal to 20y times y plus 2. And these two will be cancelled. And then you can divide this to the other side. So 0 cancels 0. 2 is 6. So 720 times 6 is 0. 12. 4320 equal to y squared plus 2y. So we arrange to have a quadratic equation like this. Use your calculator. You will have these two answers, and negative should be rejected because y represents the number of students. So therefore, the original number of students is 60. Now 13 is solving a trivial equation. The first step is we will remove the tangent into sine over cosine. Okay. The second step is we don't want to see any fraction here. So you can multiply both sides by cosine theta. So you have sine squared theta equal to cosine squared theta plus cosine theta. So once you see the cosine theta here, it means that we need to change this one into 1 minus cosine squared theta. So after that, we move all this to the other side. We have 2 cosine squared theta plus cosine theta minus 1 equals 0. So if you regard this is the variable u, then you can use the cos method. So 2 cosine theta minus cosine is 1 cosine theta. So it can be factorized into something like this. So that is cosine theta equal to 1 over 2 or cosine theta equal to minus 1. From the range, you see that if cosine is positive, it is the first quadrant, this is 60 degrees, or the fourth quadrant, 300. And minus 1, it is 180 degrees. So there are 3 answers.